Hey folks, B Mays here from RC Groups. Today we're going to be building the Armattan Mini Hexacopter. This hexacopter has the tilt mechanism on the front for our FPV camera, 3100 kV Armattan motors, and we have 6 SN20 ESCs that will come pre-flashed with bi-heli firmware. This is a relatively basic, straightforward build. Obviously there's nothing to really assemble as far as the frame is concerned. So we're just going to be spending the majority of our time going over the electronic installation. I have the 180 Morphite sitting here beside it just so we can kind of have a little bit of a size comparison. So if I take my 180 and just kind of set it right on top there, you can see that the Mini Hex is a little bigger, but it's not a whole lot bigger. This being 180 millimeters from the center of this motor shaft to the center of this motor shaft. Now with the Mini Hex, that is measured in the same way. So if we put that on the center there and this on the center here, we've got roughly 223 millimeters motor to motor on the Mini Hex. So it's slightly bigger, but still in that small form factor that's going to be super fun for FPV. This is going to be a fairly quick build actually, because obviously there's nothing to put together on the frame. We're going to add our power distribution board, our mullet, and the top plate. But basically, I mean, we're going to be doing motors and ESCs and power distribution board and mullet. That's it. This is a 4 millimeter thick carbon fiber frame. We can see that here. So this is a solid 4 millimeters. Now I don't claim to know a lot about carbon fiber other than it is super strong, but I know that it comes in grades. And I know that this is a super high grade, but again, I don't really know a whole lot about it. But it does come with a lifetime warranty. So if you were to crash and break an arm, simply send Chris at Armattan a photo of the damage and he will send you a new hex frame. Honestly though, you're going to have to crash this sucker pretty hard for that to happen. The first thing that we're going to do is install our power distribution board. We're going to start by installing the nylon hardware up through the 4 holes right here. Just push it up from the bottom. We're going to put 1 nylon nut on each one of the screws. We have our nylon hardware installed, kind of surrounding the A there. Now our power distribution board is going to sit down on here right like this. Before I actually mount it, we're going to install our 5-volt regulator onto the power distribution board. And I admit I like the way Andrew did his in his 180 Morphite build. Rather than use the headers, I'm going to solder the 5-volt Pololu directly to the power PCB board here. This is actually a lot easier than what you might think it is. So we're going to tin these 3 pads right here. We're going to tin the left 3 pads right here. These 2 pads on the far right will not be used. So we're going to tin these, and then we're going to heat it up and join these together right like this. So we're going to get a little bit of solder on these 3 pads. We're just going to tin it up to where we have just a little bit of a bubble. So this is what we have after we've tinned these. Now I just have a rubber band on my Leatherman here, so I'm not really putting any pressure at all on this board, but I'm just using it to hold this while I tin these 3 pads right here. So here's the 3 pads on the regulator tinned. So basically what we're going to do is place the regulator directly over top of the pads, right like this, to where they're lined up perfectly. And then when we heat it up, it's going to melt and it's going to be adhered right like that. Now that we have the regulator installed onto the board, we can install the power distribution board onto the hex. Now, I feel that the power distribution board being installed in this orientation will suit us best because it's a hex. So what we're going to end up with is the front 2 ESCs will solder up here. The side 2 ESCs will solder right here. The rear 2 ESCs will solder right here, and then we'll have this open for our battery cable. So what I'm going to do first is just go ahead and tin all of these connections in preparation for soldering on our ESC power wires. I have the connections tinned on the power distribution board for our ESC power wires. Lift the power distribution board back off temporarily, and I'm going to go ahead and install the motors. We're going to be using the Armattan 3100 kV 1306 motors. Same motor that we're using on the 180 Morphite. Excellent motor. Love these little motors. And I'll show you the these come in clockwise and counterclockwise. This one here is a clockwise motor. That on there, and you can tell that because the cone does not have any ridges on it. The counterclockwise motor not only says counterclockwise, but it has 2 ridges on each one of the cones. If you can see that there, 2 ridges on each one of the cones. This is a left-hand threaded cone nut, so we have to tighten to remove it. So these are all going to be self-tightening. Now on the hex, the easiest way to remember the motor rotations is when the motor is going to be spinning in a counterclockwise direction, you want to be using a clockwise motor. That's going to ensure that the prop, as the motor is spinning, will be tightening itself rather than loosening itself. So this clockwise motor is going to install right here on the top right corner, and that motor will be spinning in the counterclockwise direction. The next motor, this motor will be spinning in the clockwise direction, and we're going to be installing this counterclockwise motor. This is the one that has the 2 rings on the top. This one is going to install right here. The next one down is not going to have any rings. This is going to be spinning counterclockwise. Now we're back to a ringed cone. This is the going again with the counterclockwise marking. This one's going to be installed right here. That one's going to be spinning in the clockwise direction when it's in flight. Now we're back to a counterclockwise motor. Remember, no rings. That one's going to go right here. And then our very last one, that motor will be spinning in the clockwise direction. It is a counterclockwise threaded motor, counterclockwise threaded, and that one is going to go right there. We'll go back over that, but for now, That's what we're going to need. I'm going to go ahead and get these bolted up. Might want to take and put just a tiny dab of some kind of Loctite on there. You don't need to get carried away. You don't even have to use it. So I'm going to get these motors installed and I'll be right back. All right, we've got our motors installed. And I went ahead and used all 4 bolts, and some people only put in 2 to save weight. Me, I think it's minimal, so I went ahead and installed all 4. One thing to note, you definitely don't want to try and use these M2 by 5 screws that come in your motor packet. These aren't quite long enough. You're going to need to use the M2 by 6. As of the time of this video, Chris will be shipping M2 by 6 screws and all of the DIY kits. So now we're going to go ahead and get all 6 of our ESCs installed. The ESCs that ship with the mini hex kit are the SN20. These are going to come pre-flashed with Bi-Heli firmware. For right this moment, we're just going to be kind of pre-fitting the ESCs. I'm going to place the ESC kind of where I want it and make sure that my power wires are cut to the correct length, and I'm just going to basically do the power end here of the ESC. We're not going to connect the motor wires just yet. I'm going to get all 6 of these pre-fit the way I want them, and then we're going to go back and we're going to connect all of the motor wires, and I'll explain which ones will be soldered straight and which ones will be soldered with the 2 wires crossed. So basically, your only thing you really need to know here is your white wire is your positive, and of course your black wire is your ground. So I'm going to go ahead and get all 6 of these kind of pre-fit onto here and soldered, and I'll be right back. All ESCs are now soldered up, so it's kind of quite the mess going on here, but that's okay. We'll get it straightened up here in just a second. What I've done is I've kind of angled the wires that are coming off of the power distribution board in a way that they're going to be routed around, like for example right here, that's going to be routed around this standoff, so that when my ESC is mounted on the arm, everything's just going to be kind of routed fairly neatly. I mean, it's 6 ESCs, we can't be but so neat. Now I'll show you on the bottom because it's a little bit easier to see, but there's this oval shaped hole on every one of the arms, and you could, if you wanted to, you could run your 3 motor wires down through this oval shaped hole and mount your ESCs on the bottom. It's a couple of reasons why I'm not doing that. Mainly, if we run our wires through the hole and we mount our ESCs on the bottom, we have to come back up somewhere to get to the power distribution board. And in my opinion, there's just not a really good place to kind of come back up through the frame to get to the board. But really, the biggest reason why I'm not mounting them there is these little SN20 ESCs are, they're not the most durable things in the world. But the last thing I want is my ESCs mounted on the bottom. And I mean, let's face it, when we're flying, you know, I like to fly low. And sometimes one of my biggest things is I'll fly too low and actually skim the ground. So I don't want 6 ESCs skimming the ground. But anyway, so all of my ESCs are going to be mounted on top of the frame right here. So what we need to do at this point is we have to take our heat shrink tube and we're going to slide it over all 6. We're going to slide it past where we need to be, past the ESC. I'm actually going to slide it, you know, fairly far past because I don't want the heat starting to shrink the heat shrink tubing. But we're going to slide the heat shrink tubing over all 6 ESCs. I'm going to trim my motor wires. So basically what I'm going to do is I'm going to lay the ESC right down here like I want it. I'm going to pull the motor wires to it. All right. And then I'm going to allow a tiny bit of slack. I don't want everything on here stretched tight. So I'm going to allow a tiny bit of slack. And then I'm just going to trim the motor wires, snip, snip, snip. and I'm going to trim them where they need to be so that I can solder directly to the ESC here. I'm going to do that for all 6 motors, and I'm going to go over really quick the ESC wiring for these 3 wires and how you're going to want to solder those to the ESCs in order to ensure the proper motor direction. Now, if you get it wrong, it's not a big deal, because we can use the USB linker. We could change the parameter on the ESCs. For example, we could change to damped light, which is sort of a I'm going to call it a motor braking, but honestly, I'm not the best person when it comes to that. I just know that it works. But regardless, we can change the settings, and in those settings, we can reverse the motor direction. So if you do happen to get one soldered up incorrectly, you can reverse the motor direction electronically. But if you wire these motors up the way I'm going to tell you, I guarantee you they're going to spin in the correct direction. For the Armattan motors, that is. Now, if you've got different motors, no guarantees. All bets are off. But if you've got the Armattan motors, your wiring is going to be crossed, straight, crossed, straight, crossed, straight. So, I mean, really, it couldn't get any easier than that. So, if you wire your motor wires to your ESCs that way, you're going to have the proper direction right off the bat. So that's what I'm going to do. I'm going to go ahead and wire all of mine up, and I'll be right back. I've gone ahead and installed the JST connector right here. This is what's going to connect to the voltage monitoring port on the mullet flight control. I've installed the power wires. I've not put my XT60 connector on the end just yet. That's pretty much it. It's a downhill slide from here. We're going to be installing the mullet flight controller now. Before we do, we've got to solder on the headers. Now, typically, your headers would be installed like this, facing outward, and that works for 90% of applications. However, for this build, I'm going to be installing the header pins on the bottom side of the board facing inward. So it's going to be installed exactly like this. That leaves enough clearance for us to get the connectors installed. Plus, with them facing inward, it just makes for a really, really clean, tight build. I'm going to be doing the same thing for the voltage monitoring and telemetry pins. these are going to be installed facing inward like that. So I'm going to go ahead and get these soldered up. And here we are, all soldered up. You can see the connectors both pointing inward on the bottom side of the mullet. Now, I'm personally not going to be installing the header pins right here. I'm going to be soldering my wires directly to the pads, and I'm also going to be pointing those inward to just make the build an overall clean look. With it installed onto our model like this, the white signal wire is going to be on the top. I should mention, however, though, that if you do decide to install your header pins this way, you will need something more than just the typical standoff that we normally use, because this will not raise the flight control quite high enough. Normally, your flight control would mount like this, and there's nothing underneath of there. But in this case, if you do it like this, you're either going to need a slightly longer standoff, or you're going to want to just take two and double them up, which is basically going to mean that you need two sets of these. But if you double them up, then that'll give you actually the perfect length that you need. But just wanted to kind of throw that out there. That way you don't get to that stage of the build and be caught off guard because your standoffs aren't quite long enough. With that said, as the DIY kit comes to you, you will receive one set of these standoffs, and you can still install your header facing inward to save space, but you would want to do that on the top of the board and not the bottom, and then this one standoff would work in the traditional way. So just don't want to mislead anybody. What you get in your DIY kit is plenty sufficient to build the model. So you can see here where I have doubled up on my standoffs to allow room for my header pins. The motor connections for the hex are quite similar to a quad X. Obviously we have two more to hook up. So our motor connections is 1, 2, 3, 4, and then we bounce over here to 5 and 6. So we're going to, in my case, with the header being mounted on the bottom of the board, this right here is now motor 1, right there, and the white signal wire is going to be facing upwards. So it's going to be motor 1 connected right here, motor 2 connected right beside that, motor 3, 4, 5, and 6. So it's 1, 2, 3, 4, 5, and 6. So now we have all 6 motor wires connected to the mullet. And don't forget, one of these, in my case, I ended up using motor 1. I've installed the 5-volt wire coming from the 5-volt regulator to the center pin. So basically, I'm just going to take these and just kind of turn it a couple of times to neaten up the wires. And I'm going to install this right down onto here, something like that. So 90% of my wires are going to be encased up under the board right there. So it's gonna make for a fairly clean build. Have the flight control mounted. Looks pretty good. Basically, normally I would use the PPM receiver. I just had this laying around brand new as extra, and I may as well go ahead and use it. So that's why I decided to solder all these up and make it as compact as I can using this. The downfall to this receiver is it's a 4-channel, so I can't change from acro mode to auto level or any of that. So whatever mode I'm in is what mode I'm in. But that's how I decided to do that. I've got some temporary FPV gear just kind of wired up on there. I'm waiting on a antenna extension cable. So when that comes in, I'll be able to finalize that. So for right now, that's just going to be stuck on there somewhere. Really right now, the only thing that I have left to do is install the XT60 connector. The flat side is the positive side, and of course this other side, triangular looking side, is the negative. I've already got the heat shrink tubing. This is provided in the DIY kit, slid down on there, and I just need to solder that up. And I've not even shrunk any of my ESC heat shrink tubing yet. So basically now we're just kind of finalizing everything. So now with the flight controller installed, you can see that I have bunched all of the motor signal wires up underneath of the flight control. So when you look at it from above, you really only see the wires going in, and everything else is just kind of bunched underneath of there. It's not the neatest, but it's not that bad. And of course, with the pins being facing downward, I don't know if you can see this or not. Let's see. But even, find something to point with, even this pin right here for the voltage monitoring and our buzzer, that pin right there is facing inward. And there's, believe it or not, I mean, it looks like it's not, but it's plenty of room underneath there for these connectors. And of course, I'd mentioned earlier, basically I just had this extra receiver laying around that I kind of needed to use, and I soldered my pins to the board and just kind of tucked that right there. Depending on what receiver you have as to what you're going to do there, there's way too many variations to kind of go over anything there. One thing to keep in mind, as with all of the DIY kits that Chris sells, the flight controller as you get it will come pre-programmed with all of the PIDs for the model that you're ordering. So in this case, it's going to have all of the PIDs set probably to fairly tame settings for the mini hex. You are provided the zip ties in the DIY kit. So you just want to take one zip tie and wrap it around each ESC. You don't want to go super tight, but you want it snug enough that the ESC is not going to be flopping around. These little guys are, I'm going to say they're relatively delicate. So again, you don't want to ream on it with your wire tie, with your zip tie. That pretty much covers it. This was a kind of a quick and easy build. Again, I just kind of stuck my little FPV transmitter right there on the top plate. I've got a antenna extension cable, little 3-inch cable on order. So when that comes in, I will be using this hole right here to mount my FPV antenna. And you can see here with the camera, the tilt mechanism, I still need to get me some screws for that, but that's how that'll look anyway. So let's go over the props in case there's any confusion as to what prop goes where. Pretty much all of the 40-45 props that I've seen have a marking on them. So you're going to have some props that are like this, that are going to have the 40-45R, and then you're going to have some that are just 40-45. So all of the props that have the R, they're going to go to the motors that have the 2 rings on top. So motor number 5, motor number 3, and motor number 4 are going to have the R props. Motor number 1, motor number 2, and motor number 6 are going to have the non-R, or just the plain old 40-45 props. So hope that helps. If there's any questions, drop me a line. I'm going to leave a link in the description to the RC Groups page for the mini hex builds, and there's lots of questions and answers and custom mixes for your PIDs if you choose to go that route. It's a lot of helpful people on that thread. We'd love to see you. Thanks folks for another great Armattan build. Have a great day.